Alright, Mr. MathWell here. Here's a lesson on 8.4 in your Pre-Calculus 12 course. This is logarithmic and exponential equations and how to solve them. First, let's go over quickly what a logarithmic equation is. It is an equation where the variable is inside the log. See that? That's a special case. This is called a logarithmic equation. There's the equal sign. How do we solve this one right here? Well, if we use our laws of logarithms, this 2, remember the power law? That 2 can go up as a squared on the x. That's what I did down here. If you write it like this, the easiest way to do this question is to see that, hey, I have the log base 10 on this side and a log base 10 on this side. And I'm taking the log of x squared and I'm taking the log of 36. Same log, same base of two different things. Those two different things should also equal each other, and you'd have x squared equals 36. Now you got to be careful here, because when you take the square root, really this answer should be plus or minus 6. One of the rules that we know is that you cannot have a negative number here. So we reject negative 6. The answer is just positive 6. If you try in your calculator log of negative 6, you'll get an error. Alright, moving on. Let's take a look at this question. This is an exponential equation. Why is it exponential? Because the x is in the exponent position. Okay, we're trying to solve something that is caught up in the exponent position. Now, this is the old way that we did this in 8.3, and Adam shows us his method here from 8.3. And what we want to do is we want to get the powers on both sides with the same base. Please be careful. If you see something like this where this 2 is outside of the brackets here, you cannot multiply that in first. This is not the same as 50 to x to the plus 1. Okay. You have to get rid of that 2, divide both sides. That's where we end up with this second step. Now, we can write 25 and 125 with the same base. And that's what Adam did down here. Write it with the same base. 25 is 5 squared. This is 5 cubed. You work all this out, power raised to a power you multiply. You get now the same base, and we're going to let this equal that. Solve, we get x. All right? Over here, this is the new way to use logarithms, okay? Now, logarithms can be used in times where you can write the numbers with the same base, but also, and more importantly, can be used in times where you can't write the numbers with the same base. We're going to explore more of this in 8.4. Because what is this one again? This is 8.4. Okay, this is where we're explaining this. Sorry, I just did a 8.3 lesson 2. Ah, my bad. We'll erase that one from the video. Beep. Let's start again. Just kidding. So, as I was saying, if we take the log of both sides, it's like an operation, okay? You can just apply the log to both sides of the equation, and then you get into the log world, and then now the properties of logarithms apply, and check this out. This is the coolest thing ever. Well, maybe it's not the coolest thing ever, but it's pretty cool. This x plus 1 as an exponent here can now come down as just a multiplier in front. That is beautiful. That's how we get the x out of the exponent position. Okay, super duper important. Now, this is one of the things you could do here to solve this. I wouldn't do it this way, but this is what they did in the book. There's a bit of an easier way, I think. But anyways, if we apply these log of logarithms, okay, you can expand this out. X times this plus 1 times this, you get this. You subtract the logs here. They use this minus this as a division, right? Remember that? Then they divided off this log of 25. All said and done, they get 1 over 2 as an answer, same as above. Okay, so we're going to do some more examples and calculations here as we move through, and I'll do it my way later. But here's an example here where we're going to use logs, okay, use logarithms, where are we, up here, use logarithms to evaluate this, or to solve, sorry. So if we have 4 squared equals 3 to the power of x, you notice that 4 and 3, those you can't write those with the same base very easily, right? It's not really possible. So what do? Well, we take the logarithm of both sides. We apply or take the logarithm of both sides. Now, again, we're into log world here, and this 2 as an exponent can now what? Bonk, come down. And this x as an exponent can what? Bonk, come down. So if we do that, we have 2 log 4 equals x log 3. All right, now what's the significance of that? Well, if I divide both sides by log 3 now, I get the x all by itself, don't I? Because that's gone with that. And so we have simply x equals this value. You plug that in your calculator, and you get this number. right there. Now if you check this, you plug x in 2.5237 in for x in the original equation, here's your check. And if you test this out, 4 squared is 16, and 3 to this power is exactly 16 as well. So there you go. That's one simple example where you can use logarithms to solve an exponential equation. This is so great. Okay? So here's an example that I'll do in my next video. Why don't you stop it right now and see if you can figure this one out. Yeah, I gotta tell you, this is a bit tricky, actually, this one. So see if you can do it, and check out my other video where I actually solve this one. Okay? All right. Hope that helps. Logs and exponentials. Have a good one.